Okay, so after metamorphosis, we have parts of a function notation. So we went over function notation. And the reason why we have function notation is because when all of the mathematicians got together, they had all of their equations in equation form. So all of the equations were y equals, y equals, y equals. And they were having a hard time telling the different equations apart. So they came up with function notation because they could name the equations different names and know which equation belonged to which part. So here, the f part right here, this part that says f, that is the name of the function. And if you can't stay within the box, that's fine. That's the name of the function. Okay, the x part inside the parentheses, that's the input. That tells you what number to substitute in into the function. That's our input. That's what we're putting into the function. Collectively, the f of x, that's the output of the function. Is the same as the y. They can just name it differently. F of x, g of x, h of x, I of x, as opposed to all of them being named y. Okay, the 3x plus 4 part, that's the function. That's the function. Okay, we have a function machine here. What happens is we put in a certain number in for x. It goes through the machine. The rule gets applied, which is the function. And then we get our output number. That output number comes in. All right, I'm going to flip it over to the next page. So we just did the more practice side on this page. There's more on the left that we did not go over. That's okay because we wanted to evaluate the functions. So we have function g of x. Remember, that was the name. This is the variable that's being replaced. It's our input. And this is our function 3x minus 8. So when I want to find g of 1, that represents the x variable. So when I want to know when x is 1, what happens when I put it into the function? So that's what we're going to do. I'm going to take 3, and instead of x, I want to know where it is at 1. So I'm going to put a 1 there, and then I'm going to subtract 8. And then we evaluate it. We use order of operations. So I have multiplication first, so 3 times 1 is 3, and then I'm going to subtract 8. 3 minus 8 is negative 5. So when I have a 1 in for the function, I get a negative 5 out. That's my output. So in went 1, out came negative 5, and I applied the function 3 times 1 minus 8. Now for part B, when I change my variable, I change the number. So now I have 3 times negative 3 minus 8. See, now I've put in a different input. I should get a different output. Operate. 3 times negative 3 is negative 9. Then I'm going to subtract 8. Negative 9 minus 8 is negative 17. And that becomes my output. So when g is negative 3, I get a negative 17 that comes out. G of 0. So I'm going to plug in a 0 in for the x. So now I have 3 times 0 minus 8. 3 times 0 is 0. Still need to subtract 8. I get negative 8. So my value when g is 0 is negative 8. Now, we have f of x. F of x is a different function. I have x squared minus x. So again, my x is my variable, and I'm going to replace that with negative 4. Negative 4 is going to go into my equation. So now I'm going to have negative 4 squared minus negative 4. So that negative 4, I did put it in parentheses because I want to group the negative and the 4 together, because negative 4 squared does equal positive 16. And then I have a negative and a negative. A double negative does make a positive, so now I have plus 4. And 16 plus 4 is 20. So now I have g at negative 4 is equal to 20. F of negative 1, that means I'm going to substitute negative 1 in next. So I'm going to have negative 1 squared minus, and then I have a negative 1. Negative 1 squared is 1. My double negative turns to a positive, so I will be adding 1. And 1 plus 1 is 2. So f of negative 1 equals 2. And then we have f of 7. So that's going to be 7 squared minus 7. 7 squared is 49. And I'm going to subtract 7. 49 minus 7 is 42. So g of 7 equals 42. So essentially what we're doing here is we are evaluating the function when these x values are these particular numbers, and we're just substituting in. We're evaluating it. What does, if I put a negative 4 in, what comes out with that equation? And in this case we got a 20. If I substitute in or plug in a negative 1, what comes out? I get a 2. If I plug in a 7, substitute it in, evaluate it with 7 in there, then I get a 42. So we are just evaluating the functions at different times in the function with the variable. Okay, now it's your turn to practice.